So we will see about W after a bit. So we are just focused on this area, just this area for now, V, Y, I, L. So in forward propagation, first we will calculate V, like we already have. With that help, we will get YT, and we obviously have HT also. Anyways, we get YT, and with YT we will calculate loss. So in backward propagation, we need to go reverse. So if we calculate the loss, derivative of loss, we need to find derivative loss with respect to YT, that we will get over here, and this loss should be propagated to from where we got this YT. We got YT from V. So if you want to calculate DL, whatever loss with respect to V, we need to fetch this, and this loss should be propagated to here also, because whatever loss we have generated over here, dl by dy, that should be back propagated to here also, like dl by dy by dz, because this is a chain rule. If you want to calculate dl by dv, we need to first find the loss with respect to y, and whatever the derivative of y with respect to z, because y is dependent and z is, this is the z actually, z is independent over here, and in z itself we also have v. So v is independent, z is dependent on v, so we need to find the derivative of that also, and whatever the loss we are getting with y, this should be propagated to the stages, previous stages in back propagation. That in turn means we need to back propagate to ht also. So ht, again we have w, so whatever loss with respect to w, it will come from loss with respect to yt, so that should be back propagated through time. This is actually a linear thing, it's just going like this. But for L2, what happens, that loss should be propagated to here like this, and it also should be propagated to t0 timestamp also, that we'll see in the coming part. So as you can see, these are the equations. Now we need to first find dl by dyi, and as you can see over here, this is a gradient descent which we are going to perform. This is a learning rate. So for that we need to find the losses. First, to get dl by dw, as we have said, dl by dw, if you want to get, we need to get with respect to v, with respect to z, then we at first we need to get with respect to y, because y is the last stage. First stage is ht, and then where in it we have w, and then ht is used over here in yt, then we get loss. So if you want to back propagate, first we need to find with respect to L, then with respect to y, that should be back propagated. This y information should be back propagated to v, and that information should be back propagated to w. So we need to, in a nutshell, we need to find dl by dw, dl by dv, and dl by du, because these are three weights, as you can see, u, w, v. We will first find v, and then we can get w, then we will see u. So this we are going to perform in back propagation. So if we can get these weights with respect to loss, because loss is the output, from output we are getting calculating loss, which is the equation is this one, and we can just substitute over here, and this is old value, old value, old value, and this is new value, new. So we can update new value based on old value minus learning rate into the loss with respect to w. And as you know, if you want to, this is a basic thing, as you can show. If you are going to perform gradient descent, if your dl by w based on iterations is like on the axes, if it is positive, something like this, so we are just going to reduce it. So we are having minus, so it will go like this. If it is negative, means negative of negative, positive, so this is a negative slope, so it will go in this direction. So if dlw is positive, that means this thing, positive slope. We are having negative, so it will try to go in this direction. The loss will try to go in this direction. So new value will be in this direction. And if it is negative, the way the slope is negative, means negative of negative, positive. So our new weight will try to go in this direction, like update in this direction. So loss will try to propagate here, so it will try to reach in the global minimum.